In this video, I will discuss some of the basics concerning posture and balance. Let's begin with an overview of what I will discuss. In this video, we are going to go over some of the basics of posture and balance. We will begin by ensuring that we have some common terminology by defining such terms as posture, balance, postural control, stability, and perturbation. Next, we will discuss some issues with, functions of, and types of postural control. An important idea will be the stability-mobility continuum. Then we will apply these concepts to static standing, where we will examine the center of gravity, the base of support, and ways of increasing our ability to withstand a perturbation. Now that you have an idea about what I'll be talking about, let's get started. First, it's important to get some definitions out of the way so that you know what I mean when I use certain words. Posture is the alignment or position of the body and its parts. Balance is the ability to maintain the body's center of gravity over its base of support. Postural control is management of the body's position in relation to the task in the environment. Stability is the ability to maintain a position, known as static stability, or trajectory, known as dynamic stability, following a perturbation. And finally, a perturbation is a disturbance. For the purposes of this video, that disturbance will be an external force. All movement begins and ends with posture. So that begs the question, does faulty posture lead to faulty movement? I believe it does. Kelly Starrett refers to this as the principle of the tunnel, and I like that analogy. According to Kelly, you have to start a movement, enter the tunnel, in a good position to finish the movement in a good position or exit the tunnel. If you don't start right, you won't finish right. And if you don't finish right, your next position will be compromised. But I want to emphasize that there is no one ideal posture or position for everybody. We should acknowledge that deviations from acceptable ranges can lead, and not necessarily will lead, to musculoskeletal impairments and/or pain. The challenge is finding out what the acceptable ranges are, and if those ranges are even the same for everyone. There are three functions of postural control. They are to maintain body segment alignment in any position, anticipate changes to allow engagement in voluntary goal-directed movements, and to react to unexpected disturbances. Let's now go over the types of postural control. The first is static. This is keeping the body's center of gravity within the base of support. This happens with quiet standing, sitting, or lying. The focus of this video is on quiet standing. Reactive postural control is required when an unexpected perturbation causes the center of gravity to move away from the base of support. Anticipatory postural control is movements in anticipation of events that will cause postural changes and potential loss of balance. An example would be a heavy suitcase. You probably don't even realize the changes you're making in anticipation of lifting that heavy suitcase, but it becomes apparent if you tried to lift something you thought was heavy but wasn't. You probably had to have reactive postural control because what you anticipated was not reality, and you overcompensated for it. Adaptive postural control is modifying our movements in response to situational changes. This occurs when we learn to start making modifications based on the environment. I want to emphasize that static stability is keeping your center of gravity firmly in the boundary of the base of support. But movement requires you to project your center of gravity outside your base of support and then move that base of support. I hope you can appreciate that these two requirements are at the opposite ends of the spectrum. You can either move easily, or you can keep your center of gravity firmly entrenched within your base of support, but you can't do both at the same time. Most tasks probably lie somewhere in between these two extremes. I've thrown a couple of terms out several times already, and they are the base of support and the center of gravity. Let's look at each of these two concepts a little more closely. The base of support is an area with the perimeter made between the ground and whatever it is that you have in contact with the ground. Shown here, you can see the base of support for 2 feet in various configurations. Notice that the length and the width of the base of support changes depending on how you position your feet. Also note that if you had just 1 foot in contact with the ground, then the base of support would be the imprint made by that 1 foot. Similarly, if you had a cane or a walker, then you would have a wider base of support that would include those contact points. The center of mass is a theoretical point where, if all the mass of an object were concentrated in one point, it would be that one point. For a symmetric object of uniform density, the geometric center of that object is its center of mass. If an object is not symmetric but still of uniform density, then the center of mass would be located wherever a larger portion of that mass is. Now let's make a distinction between the center of mass and the center of gravity. To make things simple, let's assume that we are on level ground. The center of gravity is the vertical projection of the center of mass. That is, along the same line as gravity, extending from the center of mass. The center of mass and the center of gravity are the same point. The center of gravity is the vertical projection of that point, and it is only accurate in the direction of gravity. The center of mass, on the other hand, is valid in all directions. If we're talking about the vertical direction, though, we can use the terms center of mass and center of gravity interchangeably. Now I'd like to illustrate some of these concepts using static standing in the sagittal plane. In this case, we can see that the base of support is determined by the outline of the foot in the anterior-posterior direction. The center of gravity is not fixed in your body, but moves depending on your posture. For this example, though, we will assume that it's fixed somewhere within the pelvis. As mentioned previously, if we are to maintain quiet standing, we must keep the center of gravity within the base of support. That means there's a limit to how much we can sway in the anterior direction or how much we can sway in the posterior direction. If we consider the pivot point to be the ankle joint, then we have the potential to sway further anteriorly than we do posteriorly because more of the foot's length is anterior to the ankle joint center. Let's now discuss ways that we can improve our ability to withstand a perturbation, keeping with our example of the anterior-posterior direction for quiet standing. First, we can lower our center of gravity. If our center of gravity is lower, we can project our center of gravity farther anteriorly or posteriorly for the same angle of sway. Second, we can increase our base of support. If we increase our base of support, we can potentially increase our angle of sway and project our center of gravity further in an anterior or posterior direction. Next, if we don't anticipate a direction of a perturbation, then it would make sense to centralize our center of gravity within our base of support. That way we could move our center of gravity equally in either direction before it reaches the limits of the base of support. If, though, we anticipate the direction of the perturbation, then it would make sense to move our center of gravity in the direction of the oncoming force. In this example, if we know the force is in an anterior-posterior direction, then it would make sense to move our center of gravity to the anterior border of our base of support. That way, we have twice as far to move our center of gravity while absorbing that force than we would if the center of gravity were centralized within the base of support. Of course, this assumes that we guessed correctly. If we moved our center of gravity to the anterior edge of our base of support and a force was applied in the posterior anterior direction, then we would easily move outside of our base of support. Of course, we don't have to employ these strategies in isolation. We can combine them together. In this case, we would lower our center of gravity, extend our base of support, and move the center of gravity in the direction of the oncoming force. This would probably be superior to adopting any of these strategies alone. But this brings us back once again to the stability-mobility continuum. The better we position ourselves to withstand a perturbating force, the harder it will be to move, and vice versa. Like most things in life, there is a trade-off. Therefore, it is important that you adopt a strategy that is most appropriate for the task in the environment. So, when evaluating postural control, we must consider all three: the performer, the task, and the environment. So let's review what we did in this lesson. In this video, we went over some of the basics of posture and balance. We began by ensuring that we had a common terminology by defining posture, balance, postural control, stability, and perturbation. Next, we discussed some issues with, functions of, and types of postural control. An important idea that we reviewed was the stability-mobility continuum. We then applied these concepts to static standing, where we examined the center of gravity, the base of support, and ways of increasing our ability to withstand a perturbation. We only really scratched the surface of this topic with this video. There's a lot more to cover, but we can leave that for another video.